Welcome to Wisdom Outlined Coaching. My name is Askar Khan, your math coach, and our mission is helping you learn. In this lesson, we will try to understand the laws of exponents for real numbers. So let's dive into the lesson. Let's understand what do we mean by exponential form. So tell me now, what is 2 to the power 3? What does it mean? It means 2 times 2 times 2. 2 multiplied by itself 3 times. And of course, this is 8. We know that. Now, this is said to be in exponential form. I'll just write it as EF. 3 is called the exponent and 2 is called the base. Some textbooks call it as in index form. So it depends which textbook you're referring to. But nevertheless, exponential form is 2 to the power 3, where 3 is the exponent and 2 is the base. Do not get confused. 2 to the power 3 is not 2 times 3. This is wrong. It is 2 multiplied by itself 3 times. So you get now what do we mean by exponential form and what is called the base and what is called the exponent. Now, let us understand what are the laws of exponents. Let us try to understand the first law of exponents. We already know what do we mean by a to the power m. M is the exponent, a is the base, isn't it? Times a to the power n. Now, ask yourself the questions. Are the bases same? And when they are multiplied, the law says it is a to the power m plus n. So when the bases are same and they are multiplied, you add the exponents. Okay, then let's look at few examples now. 2 to the power 3 times 2 to the power 2. The best way to become a self-learner, ask questions to yourself and then explore the answers. Are the bases same? Yes. Are they multiplied? Yes. When the bases are same and they are multiplied, what do you do with the exponents? You add them. So this is 2 to the power 3 plus 2. Which is 2 to the power 5. What does it mean? It means 2 times 2 times 2 times 2 and times 2. And how much is that? It's 32. Understand how you apply the law? Let's take another example. 3 to the power 3 times 3 to the power negative 2. Okay, ask yourself the questions. Are the bases same? Yes. Are they multiplied? Yes. So what do you do with the powers? You add them. So it is 3 to the power 3 plus minus 2, which is minus 2, which is 3 to the power 1. When the power is 1, you don't have to write the power. It is understood to be 1. So 3. Understood how you apply the first law of the exponent, which is a to the power m times a to the power n is a to the power m plus n. Let's move on to the second law of the exponent. What is the second law of exponent? Let's understand that. A to the power m divided by a to the power n is a to the power m minus n. When the bases are same and when they are divided, you subtract the exponents. Okay? Let's take an example. 2 to the power 5 divided by 2 to the power 3. Are the bases same? Yes. And are they divided? Yes. So what do you do with the exponents? You subtract. So 2 to the power 5 minus 3, which is 2 to the power 2, which is 4. Good. Okay, let's look at another example. 3 to the power 8 divided by 3 to the power 5. Ask yourselves the question, are the bases same? Yes. So, subtract the exponents. 3 to the power 8 minus 5, which is 3 to the power 3, which is 27. Got it? So when the bases are same and when they are divided, you subtract the exponents. So let's move on further into the laws of exponents. Let us look at the third law of exponent. Of course, the laws are not in order. Different textbooks will give it in different order. So don't worry about the order. We are just following some number system. Now, the third law. A to the power m, the whole thing raised to the power n, is a to the power m times n. You multiply the exponents. Got it? Let's look at some examples. Example. 2 to the power 3. The whole thing raised to the power 2 is 2 to the power 3 times 2, which is 2 to the power 6. Understand? Okay, let's look at another example. 3 to the power negative 3. The whole thing raised to the power 5. Can you tell me what will it be? The law remains the same, whatever the powers are. So 3 to the power negative 3 times 5, which is 3 to the power negative 15. We will see how to deal with negative exponents later. But as for the time being, do you know how to apply the law? A to the power m, the whole thing to the power n, is a to the power m times n. Okay, let's move on. Let us understand, although it's not a law like that, but anyway, we will just try to figure out. Any base to the power 0 is 1. This is a statement that we can make. Of course, different textbooks will give you the proof of that. Over here, we are not getting into the proofs. So remember, a to the power 0, meaning any base to the power 0 is 1. For example, let's look at the example. Tell me, 2 to the power 0 is what? 1. Okay. Negative 3, the whole thing to the power 0 is what? Is the base negative 3? Yes. Is it raised to the power 0? So any base raised to the power 0 is 1. Understand this? Let us figure out another law. 1 over a to the power n. What will this be? Okay, let's try to figure out. Can I write 1 as a to the power 0? We already learned any base raised to the power 0 is 1. So this is over a to the power n. Now, question yourself, are the bases same? Yes. And are they divided? Yes. And when the bases are same and when they are divided, what is the law? We subtract the powers. So can I write this as a to the power 0 minus n? Of course. And that is a to the power negative n. So can we now then say 1 over a to the power n is nothing but a to the power negative n. Clear? Now, remember I told you we will deal with the negative exponents. So let's read this again. 1 over a to the power n. What is it? It is a to the power negative n. Okay. A to the power negative n. How can I make the power positive? Can I write it as 1 over a to the power n? Understand? Let's look at some examples over here. Tell me, 1 over 2 to the power 3. What will it be? It will be 2 to the power negative 3. Isn't it? Okay. 1 over 3 to the power negative 5. What will it be? It will be, when this comes on top, it will be 3 to the power negative 5, which will be 3 to the power 5. So in other words, when you simply bring the denominator onto the top, the sign of the power changes. Do you observe? So now you know how to deal with the negative exponents. Let's move further. Let us look at another rule or another law. Nth root of a is a to the power 1 over n. Okay? Example. Cube root of 2 can be written as 2 to the power 1 over 3. Correct? Square root of 3. Square root is basically 2 over here, like this. So it is 3 to the power 1 over 2. So understand how you apply this. Nth root of a can be written as a to the power 1 over n. Okay, let's look at this rule now. If I write nth root of a to the power m, how can I write this in exponential form? We already learned how can we write nth root of a. Can I write this as a to the power m, the whole thing to the power 1 over n? Yes. Now observe, what law can we apply here? Is this in the form a to the power m, the whole thing to the power n? What is the law? It is a to the power m times n, isn't it? So a to the power m times 1 over n, which will be a to the power m over n. Clear? So in short, nth root of a to the power m can be written as a to the power m over n. Let's look at an example how we can apply. Let's take cube root of 2 to the power 5. How will I write it in exponential form? It is 2 to the power 5 over 3. Understood? Let us look at one final law as for this curriculum. A to the power m times b to the power m. Observe, are the bases different? Yes, but are the powers same? So when the powers are same, we can write it as a times b the whole thing to the power m. Okay? Let us look at some examples now. Apply this law. 2 to the power 3 times 3 to the power 3. What will it be? Because the bases are different but the powers are same, can I write it as 2 times 3 the whole thing to the power 3? Yes, 2 times 3 is 6. 6 to the power 3. Get it? We must be able to apply the law in the reverse order also. For example, look at this. X times y the whole thing to the power 5. How can I apply the law? Can I write this as x to the power 5 times y to the power 5? Yes. So you must be able to navigate the laws forward as well as backwards. This is going to help you a lot when you are going to simplify problems where you will have to apply many laws in the same problem. Fine. I hope you understood the lesson. Thank you for watching. Do share this video with your friends and subscribe to my channel. If you're looking for math coaching classes, I have the number given in the description below. You can contact me on that number. Thank you.